Right, we'll try to give you a little support with working out these problems if we need to. These are all specific heat problems. So the first one is asking actually for mass, and Ms. Dawson was kind enough to make these slides for us. And if we look at what she's done is down at the bottom, we've taken the original formula, which is Q equals mc delta T, and she's rearranged it in several places so that if we're asked to solve for something else, shows how to do this. So, like I said, in this one, let's go through and write down what the problem tells us, because it's asking for what mass, and the temperature change goes 25 to 75. So hopefully you can do that math in your head, because that's plus 50. And if we use 2200 joules of energy, that's our C, and then the specific heat of water is given to us. Excuse me, I got those backwards. It's good to pay attention to that. So Q is 2200, and the specific heat is C. That's 4.184. So we need to plug these in. You'll see that what's missing, though, is the M, which is in this part of our formula. And she's rearranged the formula to begin with. And that's one way that we could do this to set things up. You could plug things in first, but what the formula we would end up using is this. And this is just an algebra thing. This is not, we probably wouldn't have anything this solve like this on your test, but this is a good tool to be able to use in math. Is if you want to solve for a variable that's over here, we can rearrange the formula by doing mathematically what we need to do. So if we wanted to get M by itself, we would need to divide out the C and divide out the delta T. But remember, if we do it on this side, we need to also do it on the other side. So that would also put a C on the bottom and a delta T over here. And so we would get these guys canceling out, and then our resulting formula look like this, which is the formula that she's got written down here. And then this makes the math just a little bit easier, because now, again, the thing we don't know is already all by itself, and then we can just plug in the terms that we need. Q is 2200, C is 4.184, and the change in temperature is 50. And put that in our calculator. And again, this is where you want to be careful about how you're putting things in a calculator, because it's 2200 divided by, and then if you put this in a calculator, we need to make sure that you're having these two numbers multiplied, because if you type in 2200 divided by 4.184 times 50, then you're telling your calculator actually to do this, 2200 divided by 4.184 times 50, which actually is going to make it way bigger than it needs to be, because this 50 needs to be on the bottom of the fraction. So there's a couple ways of doing that. One is typing it in your calculator properly, possibly by using parentheses, so that you could put 4.184 times 50 in parentheses in the bottom part of the fraction. That would probably be the safest way to do it. And we should end up getting a number that is 10.5. And we could leave it at this. Since this mass, and since our specific heat has grams in it, this would tell us that this is a gram for that. All right, the next slide is asking us how much heat is needed to raise 125 grams from 5 to 33, and it gives us a specific heat. So again, let's go through. And C is specific heat, Q is energy, M is mass, delta T is a temperature change. So how much heat? It's going to be our energy, 125 grams. The temperature change is going to be 5 to 33. So you put that in a calculator, and the difference between those numbers, and these our temperature is going up at 28 degrees, and the specific heat of iron is really low. Doesn't hold its energy very well, it's 0.5. So we're solving for Q. So we would use our standard formula, Q equals M times C times delta T. No need to rearrange on this one because that's our missing piece. So Q is M, which is 125, times C, which is, times C, which is 0.45, times delta T, which is 28. 25, we just need to multiply these together, times 0.45 times 28, and we get 1575. So again, this is the amount of energy that would be needed to change temperature of that amount of iron. This is the measure of energy. We end up putting a joule at the end of it. Next problem is asking to calculate the specific heat of aluminum. We could look that up in a chart, but it could be an experiment where we had a mystery metal and we're trying to figure out the specific heat of it. So again, let's start off with identifying our variables so we can figure out what we need to solve for. Calculate the specific heat, which is C. We don't know. If we had 2115 joules, that's our energy. The mass was 50 grams. And the temperature change went from -15 to 32. So the difference between that would be 47. Again, you're just looking at a subtraction problem here, 32 minus -15. All right, so in this case, we're missing C. Our formula that we start with is Q equals MC delta T. So in this case, we're wanting to get the C by itself. So we're going to do this one just like we did the first one. We want to get rid of the things over here that we don't need. And since everything's multiplied, we need to do the opposite, which is to divide. So we want to cancel out the M, and we want to cancel out the delta T. So if we do that, that's going to leave us with C. But remember, if we divide by M and delta T on the left side, we need to then have to divide by M and delta T on the left side. And so all that we've really done is we've just rearranged some of our letters in our terms to be able to get C by itself instead of having Q by itself. So these two formulas mean the same thing. They're equivalent. This just makes it a little easier for us to work with. So now we can plug in Q, which is 2115. We can plug in M, which is 50. And we can plug in delta T, which is 47. And again, in your calculator, you would probably want to do 2115 and then in parentheses 50 times 47 to put all that in parentheses together. Otherwise, you're going to get a number that's just a little bit too big. So 2115 divided by parentheses 50 times 47, close parentheses, and that gets us a 0.9. Does 0.9 seem reasonable? Yeah, because that's a specific heat term. And remember, specific heat, the highest one we've been dealing with is water, which is 4. So these values generally range from 0 to 4.1 or so for water. So that's a reasonable answer. And that's one of the things you should probably always do with a math problem is think about, is this number correct? Again, we don't have to remember units for this, but the units for specific heat are complicated. So it's a joule per gram degrees Celsius. We'll find the specific heat of this one. So let's get our letters out again. Identify everything. Find the specific heat. That means I don't know C. 158 grams. It's heated from 14 to 32. So our difference between that, now we don't say 14 minus 32 because again we're looking for what is the temperature change. So if it goes from 14 to 32, that means it's going up, and that tells us we need to have a positive answer. So we actually we subtract. It's going to be 32 minus 14 for us to get that difference. So once you figure out the temperature changes, ask yourself, does that make sense? We're getting something hotter here, so this should be going up. And Q is 485 joules. So we set this one up just like we did previously. The formula, she's already got it down here, so I'm just going to skip to it because I showed how to move that around in the previous example. So we got M and delta T on the bottom. So we don't know C. Q is 485. M is 158. delta T is 18. Then we've got everything we need to solve the problem. So 45 divided by parentheses 158 times 18, close parentheses. This is an answer of 0.17. Again, this is a specific heat, so that's a reasonable answer. It will be joules per gram degrees Celsius. So this was something, and this has very low specific heat, so it would change its temperature very quickly. Again, remember, think what this number means. It means that it doesn't need very much energy to make its temperature go up. How much heat is needed to raise the temperature of the substance? C, Q, M, delta T. So the amount of heat, that's our Q, don't know. 5.8 grams is a mass. Sample of water at about 25 degrees, so that we don't have to do the math on that one. And it tells us that the specific heat of water is 4.184. We're solving for Q, so we want to use this formula. So all we have to do on this one is multiply these three numbers together, which makes it nice and easy. So 5.8 times 25, excuse me, that's about what I'm doing here. C is 4.184, and the temperature is 25. Because we're multiplying, it wouldn't matter if we got these out of order, because you still get the same answer. Multiply those together, and we get 606.68 joules Q. Last few. All right, so looking for how much heat again. This should be an easy one. Don't have to rearrange the formula. 24 grams is our mass. Change the temperature from negative 45 to negative 10. So again, even if you put this in your calculator to figure it out, again, it's the final temperature minus the beginning. So if you put this in, it's negative 10 minus negative 45. That's an increase of 35. So I know these are negatives, but it's still getting warmer. It's going up 35 degrees. And our C value in this one is 2.06. Specific heat of ice is different than water, actually. All right, so we're solving for Q. That's our basic formula. So all that we need to do is to multiply our three values together. So where's M? It's here. It's 24. C, 2.06. Delta T is 35. So 24 times 2.06 times 35. Get a value of 1730.4 joules. And our last one here is asking about finding the mass. So we're going to have to rearrange the formula a little bit on this one. So we don't know the mass. We're going to go from 12 to 130. It's a pretty big temperature increase. So that's going to be 118 degrees. Again, change in temperature, how much hotter is it getting? Remember, this can be negative, which means we'd get a negative joule value. And C in this case is 0.385. It's probably a conductor. It's got a very low capacity, so I don't know. Actually, we do know Q. Hang on. 5,400 joules. Okay, so this one we don't know the mass. Again, she's got the formula down here. Let's say, how do we get to that? Good math skill. Not necessarily needed for our test, but we're trying to solve. We want to get the M by itself. We've already done this once, so hopefully you can remember how to do it. If we want to get the M by itself, that means we need to get rid of its partners over here. So we need to divide those out. So we'll cancel those. And that leaves us an M on the right side. But remember, if we divide something on the left, in order to keep it equal, we've got to also divide by those same things on the right. So we would have needed to put those things on the bottom over here. So we've rewritten our formula to solve for mass, and you can see that it looks just like this one that she's got here. So now we can plug in what we need to. So Q is 5,400. C is 0.385. And change in T is 118. So we'll put that in our calculator. So we're going to do 5,400 divided by parentheses 0.385 times 118, close parentheses. Make sure you're using those parentheses or it probably will mess up your math. And our mass is 118. There's a whole lot of decimals on this, and I'm not going to go into the details, but we don't want our answer to have more decimals than what we're seeing in the problem over here. So there's three numbers, our smallest terms. These have three numbers. Those have three numbers. That one's got more, but the zeros, we'll talk about one of those are important. So we don't need to add a bunch of decimals. We'll just round it to one decimal. It'll be good enough for 8th grade physical science. And again, what are we solving for? This is a mass, so the unit for this would be grams.